We present CAVA, a visual analytics system for exploratory columnar data augmentation using knowledge graphs. CAVA is a visual analytics tool for augmenting a dataset with new columns. It searches for data in knowledge graphs like Wikidata. It demonstrates how data augmentation can be effective in improving outcomes of visual analytics tools. CAVA lets users augment their data with additional attributes found on knowledge graphs. To construct a new attribute, each row of a dataset is mapped to a node on a knowledge graph. Each augmented datum is the result of a query over the knowledge graph in the neighborhood of that node. Constructed attributes can be simple, as in the area of each country, or the population of each country. But they can also be complex constructions that join through multiple entities of the knowledge graph. As an example, we can join on the average GDP of all neighboring countries. For Germany, that requires us to join through Denmark, France, and Austria, among others, to access their GDP on the knowledge graph. Let's look at an example. This dataset was downloaded from the US Census Bureau and contains information about the number of residents under the poverty line in various counties around the United States. We'll load it in and try to add on additional attributes that can help in the analysis of what causes poverty. When the system first loads, the user is shown a list of columns that are found in the dataset, as well as a table that previews what the state of the current data is. Any of these attributes can be clicked on to give additional description and then a histogram of the values that are in the current dataset. The general workflow of the system is that attributes in the current data table can be used as starting points to search in Wikidata for related attributes. So for example, maybe we want to add on some related data to the state. We can click the related attributes button, and that will make the system reach into Wikidata and try to find attributes that most of the states in our data set have available. So for example, most states in our data set have population recorded. They have a flag image. They have area recorded. For these related attributes, the system will return metadata that it can find in Wikidata. So for example, it returns the data type, so strings, numbers, date times. It'll also return a couple examples. So this is the short name of the state and a description, as well as a rough shape of the data for our data set. And if we want to join any of these attributes, we click the plus button to add them. And a little drop-down menu will show you the options for adding that attribute. So here we're going to add the state area. And that drop-down will depend on what the data type is of your joining attribute. So let's look at, as an example, population here. So population is actually being returned as a list of numbers. And this is because Wikidata has, as an external data set, it's not something that we have control over the format of, and it actually records multiple populations per state. So you don't want to return all of those populations and load them into your table. You're going to want to choose one, or you're going to want to maybe aggregate them and use a mean. So because this is a list of numbers, when you hit the plus button, you have to choose the aggregation for that list. You also have the option to just say, I don't really care, just give me any of those populations. So it just randomly samples. You can do the same thing with string values. So here for a state, there might be a couple capitals available. Let's just return any capital. And as we add these attributes, you can see that our data table updates with the values down here. Now, any of the strings that you add into your table, you can then use those as jumping off points to look for related attributes. So maybe we want to get information about the capital of the state that this row represents. So we can add maybe the inception of the capital of the state. And by doing that, you're reaching further and further out from the data that you had in your initial table. The last feature I want to highlight is this sort of complex join When you don't want to search for something directly in your table, you want to search for something further out. As an example, let's look at the county and this attribute shares borders with. So this refers to other counties that our particular county is bordered next to. And maybe we want a value like the sum of population of all bordering counties. Maybe this is interesting to us as an indicator of poverty because it says, how densely populated the area is. Well, in that case, we don't actually want to add the names of the counties into our data set. We want to join through them to the populations underneath those counties. So if that's the case, we can select the through option. So this is available when your related attribute is a collection of strings. And the system will save that shares border with here as something we can join through. So we find it in the table to the left. We go to show related attributes there. And then in the related attributes that are returned, here we see population. So we're going to say, well, okay, we want the most recent population, and a dialog is going to pop up if we do this sort of through join. And this is because there's actually an ambiguity in our join here. So there's a visualization on this pop-up that shows you what the ambiguity is and what you have to decide. So as an example, Turner County, it shares a border with 3 counties, Crisp County, Ben Hill County, and Worth County. And what we specified with is that we want each county's max population. So you can see for Ben Hill County, that's 17,000 about. And the ambiguity here is once we have that max population for each of these 3 counties, what do we want to do with it so that it then gets joined onto our table? So if you remember, we were trying to sum those. So we can select sum, and it'll show you the value that is getting calculated that's going to get passed up. And this will update dynamically. So if you change your mind, oh, I want the count, it'll change to that. So by doing these through joins, you can get really sophisticated joined data that reaches out to a lot of different pieces of information on Wikidata.
We've presented CAVA, a visual analytics system for exploratory columnar data augmentation using knowledge graphs. Thank you.